Hello students, I am Dr. Ashish Vikhar and today we will see the details about unit number 3 of theory of machines, and the name of this unit is CAMS and followers. For more information, please subscribe my YouTube channel Dr. Ashish Vikhar and visit my website also. The name of my website is www.drvikhar.com. Let us see CAMS and followers. In this unit particularly, we will start with point number 3.1, and it is related to introduction to CAMS and followers. It also explains what is CAM and follower terminology. After that, in 3.1, we will study classification of CAMS and followers. In case of 3.2, the information is related to types of follower motions and their displacement diagrams. These diagrams are based on uniform velocity, simple harmonic motion, uniform acceleration and retardation. Point number 3.3 is drawing of profile of radial cam based on given motion of reciprocating knife edge follower with and without offset. So let us start with the point number 3.1, introduction to CAMS and followers. Before that, we must know what are the uses or applications of CAM and follower mechanism. As if we want to list, then we can see that this CAM and follower mechanism is used in operating the inlet and exhaust valves of internal combustion engines. In case of internal combustion engines, there are two valves. One is called inlet valve and another valve is called exhaust valve. When the fuel comes inside the internal combustion engine through inlet valve, at that moment exhaust valve remain closed, and after the burning or after the combustion of fuel, whatever the exhaust gases formed, that comes out through the exhaust valve when it opens, and in that case inlet valve remain closed. So at the first time you will see that inlet valve opens, and after that, at that moment exhaust valve is remaining closed, and when the exhaust valve remaining open, then in that category or in that case inlet valve remains closed. So this way alternate inlet valve opening and closing of the exhaust valve is done with the help of cam and follower type of arrangement. In case of automatic attachment of machineries like paper cutting machines, spinning and weaving textile machineries, feed mechanism of automatic lathe, we can have the application of cam and follower. Cam and follower is also found in diesel fuel pumps, printing control mechanisms, as well as in wall clocks. It is also used in feed mechanism of automatic lathe. So after seeing these various types of applications, let us see some of the fundamentals related to the CAMS and follower, which is called as an introduction to CAMS and followers. What is CAM? A CAM is a rotating element that gives oscillating or reciprocating motion to the follower, which is another element of this machine by direct contact. So there are two kinematic links or elements used in this mechanism. One element is cam and another is nothing but follower. So cam is a rotating element. So here we can see, this is important, cam is a rotating element, and what it gives two types of motion, oscillating motion and reciprocating motion, and it gives that particular motion to the follower, and follower is the another element. So this way we can say this is nothing but the meaning of cam. When two links are connected either along a line or point contact, it is called higher pair. In the previous unit we have seen what is the meaning of higher pair. So in case of higher pair, there is a point contact between the two kinematic element. So two such higher pair mechanisms will be included in cam and follower system. So higher pair mechanism will be included in the cam and follower mechanism. A higher pair mechanism is also known as cam and follower. So higher pair mechanism is also known as cam and follower. This part is mainly used to transfer the motion from rotary to the linear linear to the another part. So conversion of rotary motion into the linear motion is one of the main goal is the main goal of cam and follower mechanism. A cam is a mechanical device used to transmit motion to follower by direct contact. The driver is called cam. So here the driver is called as a cam and driven member is called as a follower. In a cam follower pair, the cam normally rotates while the follower may translate or oscillate. Example is the camshaft of an automobile engine where the cam drives the push rods, which is called as a follower, to open and close the valves in synchronization with the motion of the pistons. Let us see what is the meaning of follower. Here you will see that in this picture, this is the complete nature of the follower. So this is a follower, and below to that you will see the cam. This cam shape is not particularly in a circular shape. It is having an oval shape. So a follower is a translating or oscillating mechanical member that follows the motion of the cam. So follower, what is doing? It follows the motion of cam. How is the motion of the cam? It follows the motion, which is nothing but up and down motion here in this case, in this particular sketch. It can touch the surface profile of the cam or can be spring loaded. So here you will see that the spring is nothing but available here. It can have a uniform velocity or can have uniform acceleration motion. Complicated output motion can be achieved with the help of the follower motion. So cam follower motion or cam and follower is a mechanism used to get the desired motion, such as reciprocating or translational from an available input. Cam is the driving component in the mechanism, makes sure that the follower follows the desired motion. Hence the profile and size of the cam are significant in a cam and follower mechanism. So this profile is most important. While designing the cam and follower mechanism, the main concern goes to getting the appropriate profile of the cam. The component which gives the desired motion in the mechanism is the follower. The motion of the follower is the output in the cam follower mechanism. Generally, followers are having two distinct types of motion, oscillating and reciprocating. The followers are designed in such a way that it always touches the cam during the cam operation. So let us see what are the types of cams. The cams are classified on the basis of three categories. First category is based on the shape. Second category is based on follower movement. And third category is based on the type of constraint. So cam is classified into particularly this important class based on the shape. We can have plate type cam, cylindrical cam, wedge cam, spherical cam, globoidal cam and conjugate cam. So let us see one by one. Types of cam based on the shape. You will see the first type, which is called as a radial cam or plate or disc cam. So this is nothing but the cam which is called as a plate cam. You will see the different structures which are formed using the radial type of cam. You will see here this radial cam having certain different nature of arrangement. Here you will see another nature of the cam. Here you will see another nature of the cam, and here also you will see the another nature of the cam. So radial or plate or disc cam is most commonly used due to their simplicity and compactness. It is cut from a metal disc or plate to a pre-planned shape according to the requirement. Many important cam parameters can be explained using the plate cam, like the base circle, pressure angle, pitch point. So in case of cam terminology, these points or terms are given, and on the basis of these terms we can design the cam profile. In a radial or disc cam, the shape of the working surface or profile is such that the follower reciprocates in a plane at right angle to the axis of the cam as shown in the figure. So this is the axis of the cam and this is nothing but the axis of the follower, and it is having a right angle. It is called radial cam because the motion of the follower obtained is radial. So a differently shaped radial cam you will see in the various figure. This is showing the figure of radial cam, and here you will see the follower is reciprocating. But in case of this figure, you will see this follower will not reciprocate, it is having a oscillating motion. So in this also category you will see that the axis of the follower and axis of this cam is at certain distance, but here you will see the axis is moving. Both of the axis, means the axis of the cam as well as the axis of the follower is intersecting to each other, but here you will see the axis of the cam is here and axis of the cam is having certain distance. So by this nature we can have an idea about how is the structure of a radial or plate or disc type of cam. Second one is a cylindrical cam. What is cylindrical cam? As you will see, this is nothing but a cylindrical cam shown here. It is in this category particularly the follower is reciprocating, but in this, by using a cylindrical cam, you will see that the follower is oscillating. So here there is a follower having different nature, but here you will also the having a follower, but it is having a very different nature. The cam is of cylindrical shape. A groove is cut on the surface of the cylinder and follower moves inside the groove. So here there is a groove. Also here you will see the groove and the follower moves inside the groove. The cylinder rotates and the follower oscillates accordingly. Cylindrical cam have been shown in the following figures A and B. In figure A particularly, the follower reciprocates, whereas in figure number B, the follower oscillates. So in this way, for oscillating as well as reciprocating motion of the follower, we can use a cylindrical cam. Cylindrical cams are also known as a barrel or drum cams. So barrel and drum cams, these are alternate names given to the cylindrical cam. You will see here the wedge cam. Wedge cam, you will see the wedge. Here also you will see the wedge. Here you will see the wedge, and here also you will see the wedge. In figure number A, particularly in this, on imparting horizontal translatory motion to the wedge, the follower also translate about vertically. So you will get here such type of motion of the wedge, and by that the follower rotates or follower translates vertically. In figure B, in this particular figure, the wedge has a curved surface. Here you will see the wedge is having a curved surface. The curved surface is given. The follower gets an oscillatory motion when a horizontal translatory motion is given to the wedge. When the horizontal translatory motion is given to the wedge, the follower gets an oscillatory motion. In case of figure number C, the wedge is stationary. The guide is imparted translatory motion within the constraint provided. This results in translatory motion of the follower. And in case of figure number D, instead of wedge, a rectangular block, here you will see the rectangular block or a flat plate with a groove is provided. So here you will see the groove. When horizontal translatory motion is imparted to the block, the follower is constrained to have a vertical translatory motion. So this way the wedge cam works. Next is spherical cam. You will see the spherical cam here. Spear-like structure. A spherical cam is similar to a cylindrical cam. The only difference is a groove is cut on a spear instead of a cylinder. So instead of cylinder, there is a spear. In this cam, as shown in the figure, the cam is of a shape of spear, on the periphery of which a helical groove is cut. So here you will see the helical groove is cut on the periphery. The roller provided at the end of the follower rolls in a groove, causing the oscillatory motion to the follower in an axis perpendicular to the axis of rotation of the cam. So this way this spherical cam works. Another type is globoid cams. This cam has two types of surface, convex and concave. So here it is a concave surface. In this particularly you will see the concave surface, and this is nothing but the convex surface. So this is a globoid cam. A helical counter is cut on the circumference of the surface of the rotation of the cam. So helical counter is nothing but available here. In both the figure you will see the structure. The end of the follower is constrained to move along the counter and then oscillatory motion is obtained. In this cam, a large angle of oscillation of the follower is obtained. Next cam is translating cam. As you can see in this picture, this is nothing but the structure of translating cam. Is countered or groove plate sliding on a guiding surface. The follower may oscillate or reciprocate. The contour or the shape of the groove is determined by the specified motion of the follower. Next is conjugate or dual cam. As the name implies, the cam comprises two discs keyed together and remain in constant touch with the two rollers of the follower as shown in the figure. So we will see here the figure also. Conjugate cam. So this is the cam disc 1 and this is nothing but you will see the rollers here and the follower is in the shape of that. The conjugate cam consists of two disc cams that are bolted together. This type is used for very quiet operations. Next is spiral cam. As you can see, this is a spiral cam. So spiral groove is there on this cam. It is shown in the figure. The cam comprises a plate on the face of which groove of the form of a spiral is cut. The spiral groove is provided with a teeth which mesh with the pin gear follower. This cam has a limited use because it has to reverse its direction to reset the position of the follower. This cam has found its use in computers. Next is translating cam. Translating cam, as already explained, but I am also repeating here. Translating cam has grooved or counter plate and its follower oscillate in the face of the plate. The groove or the counter has specified the motion of the follower. Translating cam is the type of cam in which cam can move in a horizontal plane. So horizontal plane motion is there. The follower attached to has the motion constrained with the help of spring. So sometimes groove cam are used in which the follower motion is achieved without the use of spring. And last is heart-shaped cam. You will see the heart shape here. This type of cam looks like a asymmetric heart. It is mainly used to return a shaft to hold the cam to set position by its pressure from a roller. So this way we can have different types of cams. Thank you very much.